Well, this has been a great afternoon in terms of the conversations and the presentations. It's great following Anna because Anna focused a great deal on material science. I'm going to focus a bit on process and where we think process needs to go in terms of the practice of architecture. But one thing that we think is really important, and it probably already exists here, but not so much in the United States, is the importance of that bridge, that relationship between the academy, the research going in the academy, and what actually happens in the profession. And Shop has always been interested in the both and relationships and how that really spurs or spawns new ideas and innovation, especially now. But to give you a general overview, Shop's been around for almost a quarter century. We've done public parks. We've done, arenas. This is the Barclays Arena here in downtown Brooklyn. We've also done a number of major projects for technology companies. This is Uber's headquarters in Mission Bay, San Francisco. The first truly breathing facade without an MEP system behind it. So, and then being from New York, we had to do some skyscrapers too. And we've done some cultural projects. This is Site Santa Fe in New Mexico, and this is the Hangil Sa Book House in Seoul, Korea. We're also doing a number of institutional projects. This is going to be the new Fulbright University in Ho Chi Minh City, which is currently in master planning. And we're also working with our federal government on a number of embassy projects. This is a new office building to support our embassy in Bangkok, Thailand. But one thing that all these projects have in common is they're all made up of different materials. And how do we, with these large projects, how do you scale these buildings to people? And I think we heard a lot about that today, which is really beautiful. Understanding how important the human scale is to our built environment and how we're able to really experience it. And how technology plays a big role now in allowing us to take traditional materials, whether it's wood or terracotta or stone, and be able to push it into sort of new ways of making, new ways of crafting, and creating that, as we heard today, that joy, that visual delight, because that's what we need in our lives. We need things that really, really excite us. I don't agree with Adolf Loos that he said ornament is a crime. We need ornament, we need detail, we need intricacy. And the thing about it right now is in order to do this, and this, again, is coming from an American perspective because architects in America aren't supposed to be involved in means and methods. We don't engage with the fabricators directly. We don't engage with the builder directly. Because we're a very litigious society, we silo ourselves in order to protect ourselves from being sued. But the fact is, in order to move things forward, to really innovate, we need to engage with every sector of the process. And so whether it's working with traditional materials or new materials like 3D printed bamboo or carbon fiber or wood PLA, it gives us an opportunity to really engage with those fabricators. And you saw some of this just now with Anna's thing. So what we need to do is we have to rethink the practice. How do we work? How do we engage? How can we innovate if we don't affect the way that we practice architecture? And so why is that important? I think we all know why it's important. We have a huge housing crisis in the United States. It's a global problem. And the fact is more people live in cities today than they live in the countryside, and it's not getting better, it's actually getting worse. So how do we deal with that problem? We know that the building industry, the huge amount of embodied carbon there. But another thing that really isn't talked about is the amount of forced labor in the material supply chain. So how do we get into that when we don't have that relationship with the fabricators or where they're sourcing materials from? And we learned during the pandemic how weak or how sensitive supply chains can be. And especially now when you start to see these moves towards challenges that are starting to appear in how we operate globally with our supply chain. So in order to address some of these wicked problems, we have to really innovate our process. And so this was an image McKinsey created back in 2017, showing where construction is. In terms of innovation, it was behind hunter-gatherers. Farmers and hunting actually is more innovative than construction. Now, it is changing. There is more automation. There is more technology being brought to the job site. But where you're seeing real innovation is in advanced manufacturing. How do we bring things that are going on in aerospace, in marine development, in terms of automobile development, how do you bring those processes into our world? And not to replace the architect or replace our relationship with materials, but how can we create a more intimate relationship with how we design and how we make? And so we've proved it out with some of our projects that we can handle a great deal of complexity. That's what's so exciting about a lot of the technologies that are out right now, is that it allows us, whether it's with AI or with model-based delivery, we can actually handle a great deal of complexity. But it requires us to engage with organizations outside our sphere of influence, in this case, working with software companies like Dassault or gaming platforms like Unity or Epic. And why is this important? Because communicating is half the battle when you're working with clients, when you're working with builders, when you're working with your consultants, is how do you visualize things? And whether it's during the design stage or when you're on the job site and you're starting to work with the build team to understand how you manage risk, or when the project's almost done and it's turned over to the people who are actually going to become the caretakers of the building. So how does the building start to perform throughout its whole life cycle? So what we've been focusing on is how we can pull some of that complexity off the construction site into more controlled environments. So looking at ideas of off-site manufacturing, design for manufacturing and assembly. And for us, it really started on certain parts of the projects, in most cases with the envelope of the building, because we're all quite familiar probably with the idea of unitized facades. So the key here is how do you manage that in a way that you're developing a design using a model-based process, but the model isn't necessarily just a representation of the project. It actually holds the instructions for how you would actually fabricate it and put it together. So think IKEA, think Lego. And if you've ever opened any of those books up, and just the joy of putting something together. But it requires us to understand material science. What are the material attributes? It also requires us to engage directly with the fabricators. So what you see here is these lightweight wireframes. This is Dassault Systems 3D Experience. Same software that's used to make rockets, airplanes, and cars being utilized here to manage a rain screen facade. And we still print out information like, again, like the IKEA sort of set, so people understand how they put it together. And if anybody's ever put a Lego kit together or an IKEA piece of furniture, there's certain fun in the whole process, but there's also this delight when it's complete, as long as you have all the screws. The other thing is how you manage this, not only in the site, but in the field. So we've created a lot of software at Shop that allow us to track things and also do point cloud analysis. This is one of the biggest challenges, is what happens on the job site doesn't always match up with what happens in the factory. So you do these scans of the construction site to see if all the hanging clips for the rain screen are in the right place. And if they're sort of off, you can fix them before the panels show up so that everything fits perfectly when it shows up on the job site. And what was so exciting about doing this project in Southern Africa was the level of complexity we were able to achieve for a fraction of the cost it would have if we had done it in New York City. So the idea here is how we can take these processes and work across different sort of countries, cultures, how we start to build a much more collaborative relationship, not only with the design process, but with the people who actually put it together. And this is really where it comes to. We all have different tools we need to use. But how do we bring that together where we're sharing everything from that single source of product data? And why is that important? Because to drive and manage complexity, we have to collaborate. We can't operate in our silos and manage risk, our own risk. We need to manage risk globally across the whole project. Another aspect, and Anna talked a little about this, is a lot of the materials that we use today are very carbon intensive, or in some cases very water intensive. And so one of the things that we've been looking at, and I think Julian talked about this too, is the move towards hybrid systems and really putting the materials or optimize material performance in order to cut down on that embodied carbon. So this is going to be Atlassian's new headquarters in Sydney, Australia. It's currently in construction, but it's made up of three main materials: a steel exoskeleton, a concrete core, and every fifth floor is a concrete deck. And built on those floors is a mass timber village. And the idea here is put the beautiful biophilic warm materials where the people are, and let those other materials help, hold up that building, deal with all the seismic and wind loads. But looking at how, working with hybrid systems, we can really begin to move the dial in terms of embodied carbon. And at the same time, start to talk about some of the things Anna just talked about, is how do we bring more natural systems into our built environment. And so this is the other area, working with Yale C, working with University of Maine's Advanced Manufacturing Center and Oak Ridge National Labs, which is a government-funded facility in Tennessee, allows us to begin to look at how we can bring bio-based material systems into the built environment. And so there's some challenges here, because you still have to deal with life safety, fire codes, and things like that. But these are the kinds of problems that you give these labs. You say, in order for us to use additive manufacturing with bio-based materials, we have to check these boxes, or you won't get a building permit. But why is this important? It's not so much about printing single-family houses, as we've been seeing. It's more about using additive processes to remove part count. And this is where we see it in aviation and rocketry, is by reducing part count, you reduce labor costs, and you also reduce complexity. So this is a good example. This is one of the smart things Elon has done, where you look at the complexity of all the manifolds and wiring on the earlier models for his rocket, and then look at the one on the right, all cleaned up. All that has been done through a very clever additive process. The same thing we could do with materials, but also understanding how those materials behave under stress. And so these are the kinds of things that happen at Yale C, at Oak Ridge, at UMaine, and it's working with them directly and telling them, this is why we want to do this, and these are the challenges that we have to address. And there's these great moments where you get to sort of jump up and down and test out the materials. But what's really exciting also about this is it's a highly collaborative process that's iterative and has a feedback loop. So as you move forward, there's always this like 2 steps forward, 1 step back. But there's constant feedback, and people are working the problem together. And so it really takes a village to make this kind of thing happen. The other thing is, how does this idea of moving towards off-site manufacturing help us to accelerate the idea of bringing more natural systems into our built environment? So it's funny, but nobody really thinks about this in New York City. They just accept it that when you build a building, it usually takes 3 years, and all those materials come to the job site. The concrete trucks, the pollution, the traffic, you got scaffolding, I got families with baby carriages, and you got noise and racket and particulates. Everybody just says, well, that's how you build buildings, But what happens if we can take all that or a majority of that, off the job site into a controlled work environment. And so what we're seeing, especially with what Julian was showing, is with mass timber, for example, that's already starting to happen. So how can we dial that up even further? The other thing is it requires architects and engineers to be more involved in understanding the ecosystem of the supply chain and understanding how we could start sourcing materials, how we can have sub-assemblies, whether it's bathroom pods or wall systems, and how we can look at different suppliers all over the world to begin to produce these elements. The thing is, it's been proven in other industries that there's huge savings. Not only in time, which is key to the developer, because the longer the project goes on, the more interest they have to pay on the loan, but in terms of waste, in terms of job site efficiency with labor. So these are all things that have actually been proven out in other sectors, but not yet in our own. And it sort of comes back to this whole idea that the model, the digital twin, is the single source of all the product data for the project. You know, we as architects now can take it to the screw. You know, we could model every element into this project. And with AI, we can accelerate that whole process. So what was exciting about this is about 7 years ago, we started another company called Assembly. And you know, what you're seeing here is Alpha Prototype, which was put together about 4 years ago. Everybody in this picture are architects and engineers, except for one licensed electrician. And the point about what I'm trying to make here is it's important that we as designers and as engineers are not only doing the design, but we're getting our hands dirty. We're prototyping and we're learning from that process. And it influences not only our design thinking, but how do we engage with the supply chain. One thing that we thought was very vitally important when we did this project is that it had to be designed for disassembly. So there's no gypsum wallboard in this one bedroom. Every element can actually be taken off the wall. So this is something you see in aviation, is that every 10 years, they strip the whole aircraft down and they upgrade the avionics. There's aircraft that have been flying for 3 decades. There's certain aircraft that have been flying for almost 60 years. But the idea here is, instead of when you build a building traditionally, it goes into a state of decay. But imagine you can constantly upgrade that building as new technology comes online. So it might decay a little, and then it pops back up again. Decays a little, keeps popping up. So the idea is, it's not about throwaway architecture anymore. You know, usually right now, the average lifespan for a building is about 30, 40 years. But imagine you could go on for 100 years. Well, then again, I'm here in Athens, and you can go on for a millennia. But the point is that the idea is this is real resiliency. This is really regenerative thinking, that the idea that the architecture can actually get better with time and not seen as something that's in a constant state of decay. So this is a great example of where that floor cassette system, and besides being a structural system for a floor cassette, you can also see those 4 round tubes. That's actually the ducts to do the supply and return air. So you're not only printing the structure for the floor cassette, you're printing all the infrastructure that goes into that floor cassette. So instead of hundreds of pieces, it's one piece. And so where we're seeing, and sort of to wrap this up, where we're seeing this is definitely in unitized facades, but also in mechanical systems, sub-assemblies. And so the idea, and Anna sort of talked about this a bit, is how do we move from centralized systems to decentralized systems? Everybody really wants to control their own air quality. They want to know how that air is behaving. Is it fresh air? Does it have any particulates in it? So the idea here is all the air for this mod comes through your facade, and it's treated and conditioned in your space. Now, with sensoring, you can really understand how airflows are behaving. And it's not too different from, when you drive your car. You have complete control over that environment. But where it gets really exciting is when you start thinking about bringing natural systems into your indoor, whether workspaces or living spaces, and seeing how they behave, not only in terms of generating oxygen or removing the particulates through the roots, but the fact is bringing natural systems into our spaces. It's been proven out. It has a huge impact on mental health. I think, this became very profound during COVID when a lot of people in New York, unlike here, don't have access to balconies. Anybody who had a balcony in New York was really living high on the hog. But in most cases, people were trapped in their apartments. So the idea is, how can you bring nature into your living spaces, especially your urban spaces? So one of the things that we've been working on with Anne and her program at Yale is how we can support the prototyping process and the testing process. So this is the modular green wall system that has actually been tested over the last year and a half at SHOP. And Anna hopefully will come out with a really cool white paper that'll tell you what this system has been doing, not just in terms of removing particulates and generating oxygen, but some other really cool things as well. So just to end on this, it's like, as I said, it's been a really great afternoon, evening to hear us all sort of talk about the same thing. It's all about how do we bring that connection, the human connection, to our built environment. And there's so many different ways, whether it's through scale, it's through materials, it's through bringing more natural systems into our built environment. But we can't treat this as business as usual. We really have to embrace how we deal with these really wicked problems and embrace these new technologies. And I know there's always been this fear that AI is going to replace the architect. I can tell you right now, there's no way the architect's going to be replaced by AI. Anytime you go to a community board meeting, there's no way AI can deal with community board meetings. So the point is, but we can't just keep working the way we've been working for the past 100 years. We have to innovate. It's all about process, and it's about material science. Thank you.